In this video, we're going to talk about special sequences, and there are three different special sequences that we're going to talk about. The first one is triangular numbers. So this is the triangular number sequence. It is generated from a pattern of dots, which form a triangle. So by adding another row of dots and counting all the dots, we can find the next number of the sequence. So we have one dot, and then I have to draw two more to get three dots, and then I draw another row below, and I get 6 dots, and then I draw another row below that, and I get 10 dots, and I draw another row below that will give me 15 dots. And in order for me to get the next term, I'm just going to copy this down real quick. You can see in each row, there's one additional dot. So this is the 15. So the next term, I have to add 6 more dots. And if I do 15, 16, 17, 18, 19, 20, 21, the next triangular number would be 21. The next special sequence we're going to talk about is square numbers, and we know what square numbers are. They are those perfect squares. So 1 to the second power would be 1, 2 to the second power would be 4, 3 to the second power is 9, and you can follow that diagonal on your multiplication chart. So the next number is made by squaring where it is the pattern. So the place of the number. So this is the first term, the second term, the third term, the fourth term, the fifth term, and so on. And then the last the last special sequence we're going to talk about is the Fibonacci sequence. And the Fibonacci sequence starts at 0, and it goes 1, 2, 3, 5, and 8. And that's kind of a weird sequence. And the way we solve this is the next number in the sequence is found by adding the two numbers before it together. So 2 is found by adding the two numbers before it, 1 and 1. The 5 is found by adding the two numbers before it. So we're going to add 2 plus 3 is 5, and so on. So if we complete the table with the Fibonacci sequence, 0 plus 1 is 1. And then we continue. 1 plus 1 is 2. And then 1 plus 2 is 3. And 2 plus 3 is 5. And 3 plus 5 is 8. 5 plus 8 is 13. And if you need to put 5 plus 8, you can add that there. And then you're going to do 8 plus 13, which would be 21. And then 13 plus 21 is 34. And 21 plus 34 is 55. And then why don't you finish out the last 4 terms in that sequence? So we have 34 plus 55 is going to be the next term, and that gives you 89. And then I'm going to do 55 plus 89 gives you 144. And then I'm going to do 89 plus 144 is 233. And then 144 plus 233 gives you 377. Okay. So let's look at some examples of this. So if we look at the first problem here, it says this square pattern represents the terms in a sequence. Identify each true statement. So we we have three different pieces to choose from. It says the sixth term will contain exactly 32 squares, the eighth term will contain exactly 14 squares, and the ninth term will contain 256 squares. Well, let's look at this. We have all right, so if we look at the first term here, we have 1 as our first term. And then we have 2 as our second term, and 4 as our third term, and then we have 8 as our fourth term. So if we see here, we have 1, and then we automatically get to 2. Well, how could we get from 1 to 2? Well, if we do 1 plus 1, that is going to be 2. And then if we do 2 plus 2, that's going to be 4. And then if we do 4 plus 4, that's going to be 8. And if we continue this, we can get the fifth term, the sixth term, the seventh term, the eighth term, and the ninth term. And so the fifth term would be, you could also multiply times 2 instead of doing the number plus itself. The fifth term ends up being 16 because 8 plus 8 is 16. 16 plus 16 gives you 32 for the sixth term. 32 plus 32 is 64. 64 plus 64 is 128. And the ninth term is 256. So if we look at which ones are true and false, the sixth term is 32. The eighth term is not 14, so that's not right. And the ninth term is exactly 256, so that one is correct. All right, if we look at number 2, the cookies are arranged in a pattern on the cookie sheet. If the pattern continues, how many cookies will be in row 7? Well, if we look at this, we started with 6, and then we went down to 5, and then we're down to 4. And so this is the triangular numbers. So our next row would be 3, and then the row after that would be 2, and then our last row would be 1. So this is row 3 and 4, and then 5, and then row 6 would have 1, and then row 7 wouldn't have any. Row 7 would be 0. Number 3, what is the 15th term in the increasing pattern shown? This is the Fibonacci sequence, and the way that I can pick that out is I have double ones out front. So it goes 1, 1, and then 2, 3, 5, 8, and 13, and it wants the 15th term. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15, and I need to fill in all those spaces to get to where I need to go. So remember the Fibonacci sequence, you add the number in front of it, the two numbers in front to get the number you're looking for. So 13 plus 8 would be 21, and then 21 plus 13 gives you 34, and then 34 plus 21 gives you 55, and then 55 plus 34 is 89. 89 plus 55 gives you 144, and 89 plus 144 gives you 233, and 233 plus 144 is 377, and 377 plus 233 is 610. So 610 is the answer to this problem. And then number 4 is the last one. It says, Ron wanted to find the rule for finding the terms in the sequence of numbers. He wrote the first 4 terms this way. So here's how he wrote it out. For each, to get from 1 to 624, he wrote 1 times 2, then 1 times 2 times 3, and then 1 times 2 times 3 times 4. If Ron continues to write terms this way, what will be the 6th term in this sequence. So we have the first, the second, the third, and the fourth term. We need the fifth term and the sixth term. And if we follow this, this is the first, the second, the third, the fourth. I need the fifth term and the sixth term still. So to find the fifth term, if I just follow the sequence, 1 times 2 times 3 times 4 times 5 gives you 120. And then if I do the same thing for 6, 1 times 2 times 3 times 4 times 5 times 6 gives you 720. So 720 is the answer here. So all with the special sequences is just a different way of looking at sequences. So it doesn't follow the same arithmetic and geometric patterns. These are the kind of silly ones that don't fit the rest of the mold.